Alright, for this video, I want to go over the path you take for factoring any polynomial. And it looks a little crazy and a little messy here, but we will go over it so hopefully you can understand how you go about doing these problems. Okay, so the very first thing you do when you're factoring a trinomial or a polynomial, sometimes they're binomials, the very first thing you always want to do is factor out the greatest common factor. Okay? Sometimes there is a greatest common factor and sometimes there is not. But you always want to look to see, can I factor out the greatest common factor? Okay. Then, after you factor out the greatest common factor, you need to ask yourself a question. How many terms does the polynomial have? All right, so we factored out the greatest common factor. Then we're going to ask ourselves, how many terms does the polynomial have? Okay, sometimes there will be 2, sometimes there will be 3, and sometimes there will be 4. And depending on the number of terms our polynomial has, that tells us what method we're going to go from there. So if we have 2 terms in our polynomial, we need to ask ourselves another question. Are these 2 terms perfect squares or perfect cubes? Or on the rare occasion, sometimes they're both. Okay, so after we ask ourselves, are they perfect squares or perfect cubes? If they are perfect squares, we're going to use the difference of the square formula. And if our 2 terms are perfect cubes, we're going to use the sum of the cubes or the difference of the cubes formula. And remember, with those formulas, we will figure out what A is and what B is, and then plug A and B into each of the formulas. Now, here's the trick. If the 2 terms happen to be perfect squares and perfect cubes, always do the perfect square rule first. Okay? Sorry, I meant to zoom in here. So we've got, are they perfect squares or cubes? Squares, you use the difference of the square formula. Cubes, we are going to use the cube formula. Okay, then if the number of terms that we have are 3 terms, we're going to use the basic 3-term factoring, which is the factoring that you're probably used to hearing. If our A is 1, we find the 2 numbers that multiply to get to the last term and add to get to the first term. Okay? Now, if the term is not 1, I like to take my A term, multiply it by the C. Then we're going to factor using the process as if A was 1, which is this step right over here. Okay? And then, once we have the polynomial factored, or the trinomial factored, we will we will divide the constants in our factors by our first term that we multiplied, reduce our fractions, and then any denominator that remains, we bring it up. Okay? So that's what we do if there are 3 terms. If we have 4 terms, I think this is the hardest thing when there are 4 terms. When there are 4 terms, we need to factor by grouping. And my recommendation is always factor the first 2 and then the last 2 terms together. And then if that combination does not work, even rearranging them and then factoring, if none of the arrangements work of going first 2 to the last 2 terms together, then we'll factor 3 terms to 1 term. So factoring where we go the first 2 terms and the last 2 terms together, first we group the 2 terms, then we take the greatest common factor from each group, and then we factor the common binomial out from each of the groups. And then we have our factoring. Okay, if that does not work though, and we need to group 3 to 1, factor what we're going to do is we're going to factor 3 of the terms together that are a perfect square trinomial. Okay, then we use the difference of the squares because it will end up being in the a squared minus the b squared. Okay, so if you feel like you've got a good grasp on how to do this, then that is great. Here I'm going to do a couple example problems just so you see a bunch of different examples, but if you need to reference back to this flow chart, maybe take a picture or screenshot of it so that you have it down to help you with the flow of how you factor. Now really quick, there is one important thing I want to go over after we do this whole flow chart is after you factor, you need to make sure that every single one of your factors are prime. If you find a factor that is not prime, meaning it can't be factored any further, so if you find a factor that can be factored more, then you keep following these steps. Okay? So just keep that in mind when you do these problems. Okay, so for this problem, we have 50r squared minus 32. So the first thing I'm going to do is look for a greatest common factor. And in this case, between 50 and 32, it looks like we have a common factor of 2. So I'm going to factor the greatest common factor out first. 50 divided by 2 is 25, r squared, and 32 divided by 2 is 16. Okay, now after we factor out the greatest common factor, we want to look and see how many terms we have. In this case, we have 1 term, 2 terms. In this case, I have 2 terms, and each of my terms are perfect squares. So that means if they are a squared minus b squared, there has to be a minus sign in between. Then we're going to go a plus b, a minus b. Okay, so 25, 5 squared is 25, and for r squared is r squared. For my b term, 4 squared is 16. So then we go and we plug those into the formula, we get 5r plus 4 and 5r minus 4. Don't forget the 2 that you factored out in front. That is part of the factoring. And there we go. All right, let's try B here. This one's kind of tricky, but we do need to go and find the GCF first. I wrote these problems so that they did both have GCF so we could kind of see. But here I have the GCF between 18, 21, and 6. Looks like that would be 3. And I have x cubed, x squared, y, x, y squared. So it looks like 3x is my GCF. So we are left with 6x squared plus 7xy plus 2y squared. Now, when you have a variable at the beginning term and a different variable at the last term, they go into their factors with a at the beginning and the end. So it's just kind of like a happenstance. It's not too big a deal. It's really the same process. Now, I have this 3x factored out, but the polynomial now that I'm trying to factor has 1, 2, 3 terms. Since there are 3 terms there, I'm going to factor using the basic trinomial factoring. Okay, so what I want to do, how I do this, and you might have a different way and that's fine. I'm going to take this 6 and multiply the 2. I'll go back and divide that, balance that back out there at the end. But I have, my 6 goes into my 2, so I end up with x squared plus 7xy plus 12y squared. Okay, so what we are going to do is we're going to try find two things that multiply to get to 12 and add to get to 7. Well, that's 3 and 4. So because that is 3 and 4, when I factor this, I get x plus 3y, x plus 4y. Now we must not forget that 6 was multiplied, so I'm going to go back and rebalance it out by dividing. Okay, then we reduce 6 is the same thing as 1/2. And 6 we factor out a 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. Now, a total factor of 6 will divide out. So here 3 divided out and here 2 divided out. And 3 times 2 is 6, and that is what we multiplied originally. Okay, now after we reduce our fractions, we just bring those denominators up. And that is our full factoring. I'm going to go look at each one of my terms, make sure that they are prime all the way. So I have 2x plus y can't be factored further, and 3x plus 2y can't be factored further. So that is our fully factored trinomial. All right, on C, we have no greatest common factor, and usually when there's 4 terms, there's not going to be a greatest common factor. But we've got our 4 terms here, so I'm going to start by grouping this 2 to 2. Usually you know it's 2 to 2 when you have easy to find common factors from each group. If there's not an easy to find factor of each group, then you're probably going to have to go 3 to 1. Okay. So in my first group, I'm going to factor out a 4x squared, and I am left with x plus 2. On my second group, I have a negative 25 that I'm going to factor out. And let's see, 25 divided by 25 is x. Negative 50 divided by negative 25 is positive 2. Okay, now I've factored the common factor out from each group. They should have a binomial that is the same. So we will factor that binomial out. If that's tricky for you, you can go back and watch my video on factoring by grouping. All right, so we're going to divide this whole group by x plus 2. We are left with 4x squared. And divide this group by x plus 2, we have minus 25. Okay, so we just factored by grouping. Now there is something here. This x plus 2 is prime. We can't factor it further. But we can factor this 4x squared minus 25. There are 2 terms and they're both perfect squares. So because of that, I'm going to factor this using the difference of the squares. So we end up with x plus 2 times 2x plus 5, 2x minus 5. And we have fully factored my factoring by grouping problem. So always check to make sure that you can't factor any of the terms further. Usually if you have a squared or a cube left, you want to check and see if you can factor it more. All right, I do have one more to show you. This is actually a pretty simple one. Let's say I have x squared plus 3x plus, let's go 15. Okay, so I want to try here, it's a trinomial. So I'm going to look for 2 things that multiply to get to 15 and add to get to 3. Well, the factors of 15 are 1 and 15. They have to be the same sign. We've got 5 and 3, and neither one of those are going to add to get to 3. So because of that, guess what? We can't factor. We can't factor this. So because we can't factor a trinomial, we will call it prime. So every once in a while you'll see something like that. So I just wanted to call it to your attention. Now, if you want to see more practice with these, you can go back and watch previous videos where we've talked about each individual method. But I will also be making a video where we do a bunch of extra practice problems, so you can look for that as well. Some extra practice factoring.